status, and so on. So we know that networking is up and running, and ifconfig tells us that the interface is up and running. But how do we go about making changes to the interface? Supposing we wanted to, let's say, add another IP address or 2 or 3, or even just make general changes. Well, there are multiple tools. For example, system config network, and depending on the option or the version that you'd like, so we'll just indicate asterisk, we'll launch a GUI or text-based application which allows you to make changes to your networking interfaces. So network interface configuration. With that said, let's launch one of the tools on our local system by executing system config network. We'll tab it out, and there you see multiple options. We've got network, network GUI, text user interface, and a command line utility. The command line utility by default enumerates all the directives that are set on all of your interfaces. So here we see ETH0's hardware address, its type, its net mask, its IP, and various settings. We see a list of hosts, DNS information, ascertained from etcresolve.conf, and basically the runtime environment of networking on this system. You may also set directives using the command version of the utility. But how about just plain system config network? This utility brings up a GUI environment like what we're seeing here that has been within the Red Hat environment for a long time. It's a very simple utility. Not as complex or as friendly as YAS within SUSE Linux, but it's useful nonetheless. It displays the devices that are attached to the system, such as ETH0. It tells you the status, its type, its nickname, which doesn't have to be whatever the operating system assigns. There's a hardware tab which reveals information about the interface. You double click on it, it tells you the assigned alias and any other settings that are applicable, and you even have the option here to set those resources such as a desired interrupt, memory, items that are self-configuring nowadays anyway. You could even reassign the device to a different ETH value such as ETH1 and so on. There's a tab for IPsec. It's supported by the kernel, which allows you to communicate with IPsec peers. There's a tab for DNS. You can configure primary, secondary, and tertiary, which updates ultimately your etcresolve.conf file. Hosts updates your etc hosts file with entries that are useful for communications. Here we see one for localhost, another one for the fully qualified domain name of the local system, and one from our Debian studies. So this interface, this network configuration interface, allows you the flexibility of updating multiple text files that are used by the networking environment, by the network startup scripts. Now if you want to modify this logical interface, ETH0, double click on it. It brings up an interface, another GUI, with some key options that can be specified in the appropriate ifconfig-eth text file, in this case ETH0 beneath the network-scripts subdirectory. The one warning is that you try to refrain from using multiple methods to update your networking configuration, because the GUI, as well as the text version of system config network, will update the same text files. So note, either update your net configuration manually from the shell or using the system config network set of tools to avoid losing settings. In other words, you may modify the configuration file which controls ETH0 beneath the network-scripts directory manually, then make a change using the GUI, and then realize that you've lost the changes that you've made manually. So in here we see common settings such as on boot equals yes, or activate device when computer starts. This is equivalent to on boot equals yes, and we can confirm that by navigating to the shell briefly. Let's find a separate window on our local system. And this is on the remote system, so we'll just exit the shell, then navigate to etc sysconfig network-scripts, and we'll just cat the contents of ifconfig-eth0, where you'll find that the device's name is ETH0, and the on boot is set to yes. On boot is set to yes is equivalent to activate device when computer starts. Allow all users to enable and disable the device is equivalent to the user control feature, which defaults to no but can be set to yes to allow non-root users the ability to make changes to the configuration. For example, for those folks using mobile computers who are not logging in as the root user. Enable IPv6 configuration for this interface is disabled by default in this interface. However, it's configured one file up in the network file, so it gets enabled anyway. Networking IPv6 equals yes. This global directive overrides the context or interface context sensitive directive. Whether or not you'd like to obtain your IP using DHCP. If this were set, the static entries that you see here wouldn't be here, and the boot protocol would revert to DHCP as opposed to static. But because our address is assigned statically, as you see below, it's indicated in the ifconfig-eth0 file. If you'd like to set your MTU to some other value, you can do it here. It's set to 1 by default. We see a tab for route. If there are special routes that are to be added through this interface, you can click on Add, and a route file that's tied to this interface will be created in the network-scripts directory. So if there is a subnet or a specific address that you need access to, create a route with the interface, the system-config-network interface, and this will place the item in the network-scripts directory. Hardware device. ETH0 is assigned to this Intel interface. It can be changed, and it's bound to a specific MAC address that's tied to the network card. So this interface allows you to make these types of changes to the interface, but there's nothing that we'd like to change at this particular point. DNS is set to 75.100, but we could add a secondary just to show you how it gets updated from the shell. For example, let's add our 199 box, which currently is not a DNS server, to the mix. We'll go ahead and click on Save. System config network changes are saved. You may want to restart the network and network services for it to take effect. Generally, that's not necessary. From the shell, if you cat the contents of etcresolve.conf, you'll see the new entry for .199. So when you make a change using the GUI tool, it updates different files depending on the change you've made. This is the DNS configuration file, whereas etc hosts, which also gets updated from system config network, is a static list of hosts, including yourself, all updatable using system config network. Now, what about this idea of creating aliases? We like to show this example because it's a way to provide additional IP addresses to your interface. So let's go ahead and indicate that. Sometimes, especially on a web server, you may want to supply your users with multiple means of getting to the server, perhaps for distinct SSL websites. So IPv4 aliases. To configure an alias from the command line so that it's available now at runtime, execute ifconfig. Ifconfig is the primary interface configuration tool. The changes you make with ifconfig will not persist when the system reboots, but the changes that you make will persist so long as networking is running. It's a great way to test settings. So for example, our host currently has an IP of .10. Ifconfig will confirm that. Let's ping 192.168.75.11. It doesn't respond, so we should be safe to assign that alias using ifconfig eth0. Now when you create an alias, you use colon and an alias number such as 1 followed by, or 0:0, that'll work as well, followed by the IP address that you'd like to assign with optional net mask and other items. So 7511 will be the alias that we assign, and the kernel will make the system and its services available using this alias. We go ahead and Control-Shift-V, echo the exit status, and then clear screen and rerun ifconfig, where you'll now see, in addition to the original eth0, ETH0:1, which is an alias interface, which can be referenced. Now, we don't need to specify broadcast and subnet mask. These values are derived from the primary interface. If we ping sending 3 packets to 192.168.75.11, we'll see that it responds. We'll give that a try, and there you see it responds accordingly, telling us that .11 is now accessible. How about trying this from a remote system, such as Linux CBT Serve 4, which currently has one IP address configured, .199. We'll ping, sending 3 packets to 192.168.75.11, and it responds. .10 also responds. We may even SSH back to 192.168.75.11, and we'll be forced to accept the public key, authenticate, and gain an SSH session. If you recall earlier when we mentioned using netstat, any service such as SSH, which is bound to all IP addresses, in this case bound to IPv4 and 6 indicated by the colons, then it will pick up the service, that is, on all IP addresses, including new aliases. So ifconfig serves as a tool for manipulating your interfaces. ifconfig-a dumps all possible interfaces, and ifconfig-help dumps all possible options. You can add aliases as you see fit. The aliases may also be based on a totally different subnet. They may not be the same subnet. So for example, ifconfig ETH0:2 10.168.76.11, for example, assigns a totally different IP address to the same physical interface, which can be accessed from hosts on the same subnet with a similar subnet address prefix. So let's go ahead and assign that locally and echo the exit status. Now let's reset the buffer and rerun ifconfig. We will see, in addition to ETH0, ETH1, ETH2, ETH02, with a totally different IP address of 10.168.76.11, an address we picked out of the sky. The 10 we picked because of its RFC 1918 implications. But apart from that, the address is now accessible to any host on the subnet. Or if we have routing properly set up, the router will route traffic back into this 10.168.76.11 address. That's the beauty of creating aliases. Now, insofar as making aliases stick, in the etc networking scripts or network scripts directory beneath sysconfig, you'll need an item, an entry, such as the ifconfig ETH0. So for example, copy ifconfig ETH0 to ifconfig ETH0:1, and then modify the changes, or modify the file to reflect the changes that we've made. So if cfg ETH0:1, it needs to be escaped, and then just change this from what it currently is, .10 to .11. Everything else remains the same. Now when you restart networking, ETH01 will be brought up, but ETH02 will not be brought up. So let's just ensure that we list that note to ensure that aliases persist. Do the following. Copy etc sysconfig network-scripts ifconfig-eth02, the same directory, ifconfig ETH0:1, the name of the interface. Then 2, modify ifconfig ETH0:1 to reflect aliased IP address. Another note, aliases do not work with DHCP interfaces for obvious reasons. When you define an alias, you know exactly what IP addresses you intend to assign to that Ethernet interface. So keep that in mind. So that's a little bit about how interfaces are brought up in the environment. Again, in the network